So here is our shape that we started with. We've drawn this by hand, and we drew it on the calculator. I think we drew it on the calculator, right? Where is that graph? I lost my graph. Here we go. We drew this by hand. Hopefully, I think we drew it on the calculator. Anyway, there it is, 7 sine of 3 theta. And so the next question is, what is the slope of the tangent to one of these curves? So what is the sort of rate of change that goes around the corner? So your calculator, can draw pretty nice polar curves. You know who can draw really nice polar curves? Desmos. Desmos can draw sweet polar curves. And there's the one we're talking about. And so you can see it's very detailed and clean. All right, so what we're going to do is we're going to find the tangent to the curve at theta equals pi over 6. So we'll be able to figure out that pi over 6 is going to be this maximum over here. The reason that we know that is because the sine function attains its maximum at theta equals pi over 2. We've got sine of 3 theta, so if 3 theta equals pi over 2, then theta equals pi over 6. So this maximum occurs when theta equals pi over 6. In fact, you probably noticed when you were drawing this graph, when you got to theta equals pi over 6, you had r equals 7, which not coincidentally is that number right there. So the maximum of the function r, which is a concept I hadn't even thought about until just now, but we could do stuff like that. Now, like at what point is the graph farthest, for what value of theta is the graph farthest from the origin? So you would do dr d theta and find where dr d theta changes from positive to negative. Yeah, we're not doing that though. We got plenty of other things to do. We're going to find the equation of the line tangent to the graph. We need to say at t equals, because it depends on what the t equals, at t equals pi over 6, which happens to be that maximal extent of the floral petal, the roseate petal, if you will. All right, so here's what we do. In order to do this, we use theta as a parameter. So the problem is this. The idea of slope is inherently rectangular. So, dr d theta is not going to tell us the slope, right? Dr d theta on this one is always 1 over 2 pi. What does that mean, right? It means sort of how fast the function is moving away from the origin as theta increases. That's why this one's constant. That's why finding out where dr d theta changes from positive to negative would tell us where this maximum is, right? But that's not going to tell us the slope of the line, right? So if I want the slope of the line, it sort of looks like it might have slope -1 just from looking at the picture, right? So if I want the slope of this line, I need rise over run, right? I need delta x and delta y. So that's sort of the challenge, is I don't have x and y, but I can get x and y. So what you do is you use theta as a parameter, and then you can, we already know that x of theta is equal to r cosine theta, and y of theta is equal to r sine theta. So we can already sort of parameterize x and y in terms of theta. Two functions, x and y, both depending on theta. But they also depend on r, so we're going to sort of fix that up. All right, so what we're going to do is we're going to look at our function. So we have this. We have r equals 7 sine of 3 theta. So we're going to create a parametrization since x of theta equals r cosine theta. All right, so here's the trick. We know what r is in terms of theta, so we can just substitute that. So then this equals 7 sine of 3 theta times cosine of theta. I think I have an extra parenthesis here. I mean, I could put a parenthesis there, but I think I'll just scribble it out. All right, and then so y of theta is equal to r sine theta. All right, but r is 7 sine of 3 theta. So that's 7 sine of 3 theta, sine of theta. All right, now x and y are a parametric function of theta. So I just have to remember that for a parametric function, dy dx, which is what I need here, is equal to dy d theta over dx d theta. Remember, when we did parametrics, we did dy dt over dx dt. Theta is just playing the role of t. All right, so that means we need dy dt, dy d theta, and dx d theta. So here's our x, all right? We need dx d theta, all right? And we need dy d theta. So you could right now pause and as an exercise and practice, just do what is dx d theta, what is dy d theta. It's product rule, right? So you have to do product rule on both of those. So I will, you could do that on your own and come back. Hopefully you've done that by now. So I got 21 cosine of 3 theta cosine theta minus 7 sine of 3 theta sine theta. That's my dx dt. And, sorry, that's my dx d theta. We don't have a t here. And then my dy d theta, I got 21 cosine of 3 theta. So the 21 is from the chain rule, 7 times 3, right? Sine theta, and we're using f prime g plus fg prime. This one turned out to be minus because the derivative of cosine is negative sine. No, plus 7 sine theta cosine theta. And there you go. All right, those are my derivatives. Now, since I want the rate of change at t equals theta equals pi over 6, so I need to know what dx d theta at theta equals pi over 6 is. So dx d theta evaluated at pi over 6 equals, and dy d theta evaluated at pi over 6 equals. I mean, I should say theta equals pi over 6, but I didn't. All right, so you can work that out. It's 21, you know, sine of pi over 2, cosine pi over 6, blah, blah, blah. It turns out to be negative 3.5, right? And dy d theta, it's going to be 21 cosine pi over 2, sine pi over 6, blah, blah, blah. And it turns out to be 7 square root 3 over 2. All right. Then dy dx evaluated at theta equals pi over 6. So here it's really important for me to put the theta equals because theta is neither variable here. So it's dy dx when the theta is pi over 6. Well, that's equal to dy d theta evaluated at theta equals pi over 6 over dx d theta evaluated at theta equals pi over 6. So we now know that that is 7 square root 3 over 2 over 3.5, which by the way is 7 over 2. Right? That equals negative 7 over 2. So this equals negative square root 3. That's what dy dx is. Okay, so can we use that to write the equation of the line? All right, this is the slope. So we can already say the slope of the tangent when theta equals pi over 6 is negative square root 3. So I think we'll go to the next video to use that to write the equation of the line, but it's not hard to do. You should try doing it. You know, just figure out at theta equals pi over 6, what is x, what is y, then you got an x, you got a y, you got a slope, and it's algebra 1 to write the equation of the line.